All right, this is day 6 of our unit on matrices. And today we're going to practice finding the inverse of a 2x2 matrix, if it exists. And then we are going to talk about how to find the area of a triangle using matrices. All right, so problem number 1. The way we find the inverse of a matrix is a two-step process. First, we need to find the determinant. Now remember, to find the determinant, we just do the down diagonal minus the up diagonal. So we're doing the down diagonal and then minus the up diagonal. Okay, so the down diagonal here is negative 20. And then that's going to be minus, and the up diagonal is negative 8. Alright, so it's negative 20 minus negative 8. Don't forget that minus and negative is addition. So this is really negative 20 plus 8, which is going to be negative 12. Okay, so that is the determinant. Alright, so now if we want to go on and find the inverse, alright, the inverse, let's say this matrix was matrix A. If I want to find the inverse of matrix A, which I will call A inverse with a little negative 1 on it, what I need to do is I need to take the reciprocal of the determinant. So that's going to be negative 1/12. Alright, look, basically I'm dividing everything by the determinant, but multiplying by 1 over 12 is the same thing as dividing by 12. But later on, it's going to be more useful to think of it as dividing everything by negative 12. Anyway, so I need the reciprocal of the determinant. Now in here, we're still working with these diagonals. I guess I could just use this. But the down diagonal gets reversed, and the up diagonal gets negated. Alright, so if you remember the cha-cha slide, or if you've ever heard it, there's a part in there where the guy goes, reverse, 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 reverse. But instead of reverse, reverse, I always say reverse, negate, reverse, negate. Because on the down diagonal, we reverse. So instead of 5, negative 4, I'm going to have negative 4 and 5. Okay, I reversed. And then on the up diagonal, I'm going to negate. Alright, I think I'll change colors just to make a point. So instead of 4, this is going to become negative 4. Alright, I negated that. Instead of negative 2, this is going to become positive 2. Okay, so I reverse the down diagonal and negate the up diagonal. Reverse, negate. Then I have to go back and multiply everything by negative 1/12. In other words, I need to divide all of these by negative 12. Okay, so that's going to be like this. So I'm going to need a little bit more space to do it. So it's like I have negative 4 over negative 12, and I have 2 over negative 12, and again I have negative 4 over negative 12, and I have 5 over negative 12. See what I mean? This whole multiplying by the reciprocal thing, what it really is we're dividing everything by the determinant. So we took each one of these and we really are simply dividing by the determinant. Okay, and then it's just a matter of reducing. So if I reduce all this, obviously a negative divided by a negative is a positive, and 4 over 12 reduces down to 1/3. Alright, same thing down here, that's 1/3. Alright, this is going to be negative because a positive divided by a negative, and this is going to reduce down to 1/6. Okay, and finally we have negative 5 over 12. That doesn't reduce, so we just leave it alone. And there it is. This is the inverse matrix right here. All right, number 2 is the same way. Now, if you just sat there and watched me do number 1 because you had completely forgotten how to do it, please do not just watch me do number 2 or just copy off of me. Pause the video right now and do number 2 yourself, and then check your answer. All right, but let's assume you did that. So now, let's call this matrix A so I can just refer to it. So again, if I'm supposed to find the inverse, the first thing I need to do is find the determinant. Whoa, messed that up a bit. So I'm just going to find the determinant of matrix A. And the determinant is that down diagonal minus the up diagonal. So the down diagonal, that's -9, minus the up diagonal is +10. Okay, so -9 minus 10, that's -19. So there is my determinant. That's the thing that later on I'm going to be dividing everything by. So now, if I want to find the inverse, which is like this, I'm going to be doing -1/19 times. Now, remember, reverse negate. Reverse the down diagonal and negate the up diagonal. Let's see. So, the down diagonal, the 3, the -3, reverse that. So that's -3, +3. Now I'm going to negate the up diagonal. Okay, so the -2 and the -5, they're going to stay where they are. They're just going to change signs. So the -2 becomes 2, and the -5 becomes 5. Okay, reverse negate. All right, and then I just need to divide everything by -19. Okay, so this is going to be like -3 over -19, and 2 over -19, and 5 over -19, and 3 over -19. Well, none of this really reduces, so I probably could have skipped this step and gone straight to the final answer. Because the only thing that really changes is a negative divided by a negative is a positive. So this would be 3 over 19, and -5 over 19, and -2 over 19, and -3 over 19. So this is the inverse. All right. Let's see, you got a couple more of these. All right, and we're just practicing over and over again. So again, the rest of this is the same as what I've already done. So if you understand 1 and 2, you should be able to do number 3 and 4 on your own. So please pause the video. If you haven't already done number 3 and 4, you should not be watching this video. Stop the video, do number 3 and 4 yourself, and then start the video. Number 3, again, if I call this matrix A, the first thing I need to do is to find the inverse. I need the determinant of matrix A. So that's down diagonal minus up diagonal. So down diagonal is 12 minus up diagonal, which is -10. Minus negative is addition, so this is really the same thing as 12 plus 10, so that's 22. Okay, so there is my determinant. Alright, that's the thing I'm going to be dividing everything by. Like, remember, when my determinant was -19, I divided everything by -19. When the determinant was -12, I divided everything by -12. So I'm going to wind up dividing everything by 22 later. Alright, now, but dividing what? So if I want to find the inverse matrix, fine, I'm going to have to divide everything by 22. So that's why I write 1 over 22. But I need to reverse negate. From the down diagonal will have to be reversed, and the up diagonal will need to be negated. Okay, so first the down diagonal reversed, the 3 and the 4. Okay, these get reversed. So the 4 is going to go here, and the 3 is going to go here. Now the up diagonal does not get reversed. It gets negated, meaning the signs will change. So this -2 will turn into a +2, and this 5 will turn into a -5. So we reversed and we negated. Reverse, negate. Now, all I have to do is divide each of these by 22, and that's it. That'll be my answer. Okay, so this will be, all right, maybe I'll zoom in. So this will be 4 over 22 and 2 over 22 and -5 divided by 22 and 3 divided by 22. All right, you can probably see that a few of these will reduce. All right, these two on the left will reduce and these two won't. So just reduce what you can, and then that'll be the answer. So reduce this, so this will be 2 over 11. So this will be 2 11ths, and this will be 1 11th. And this is going to stay -5 over 22. And this is going to stay 3 over 22. And that is the inverse. That's the answer. Alright, so there's the answer right there. Now, let's do the last one of these, and then we'll move on to that area business. Okay, one more time. I will call this matrix A. So I need to first find the determinant of matrix A, which should be the down diagonal minus the up diagonal. Please do not watch this unless you have already done it yourself. I've done 3 examples now, so there's no excuse for if you're sitting there and your number 4 is blank, you should not be watching this video. Do it yourself and then come back and check. So let's see, down diagonal, up diagonal. So 4 times 2 is 8. And then 3 times -2 is -6. All right, of course, this is really 8 plus 6. So that's 14. So that is my determinant. Okay, fine and dandy. So this is what we'll be dividing everything by later. So that's why we're gonna have 1/14 times stuff. Okay, now since we're building the inverse, okay, that's what we're looking for, is the inverse. All right, with the little a and -1 is the inverse. This is when we do the reverse negate thing. So the down diagonal should be reversed. Okay, so that is why the 4 and the 2 are going to become 2 and 4 because they're reversed. The up diagonal gets negated. The 3 and the 2 don't move. It's just the 3 becomes -3 and the -2 becomes a +2. All right, reverse and negate. So now I just need to divide everything by 14, and that's really all there is to it. It's just that easy. Okay, so this is going to become 2 over 14 and -3 over 14, and again 2 over 14 and 4 over 14. All right, so that is going to give me 1/7 and 1/7 and
Faculty and staff, please excuse this interruption. Just a reminder that students will be testing this afternoon starting at 12:30 in various locations here on campus. If you have a student in your classroom that is supposed to be in the graduation test this afternoon, please send them to lunch right now.
So there is the inverse. Now, we can use this formula to use matrices to find the area of a triangle. All you do is, if you know the vertices, you stack up the vertices right here. Okay, that's one vertex, that's another vertex, that's another vertex. So you use the three vertices to build the first two columns of a 3 by 3 matrix. The third column is just always ones. Now, remember that these straight lines that sort of remind you of absolute value, in the context of matrices, this has nothing to do with absolute value. It means find the determinant. So we'll have to remember how to find the determinant of a 3 by 3 matrix. And then at the end, we will take half of whatever we get. The plus or minus is just there to make sure our answer is positive. You can't have a negative area. So if the determinant is a negative, then multiply by negative 1/2, it'll be positive. If the determinant turns out to be a positive number, then just multiply by positive 1/2, it'll stay positive. Just make sure your final answer is positive. So looking at number 5 as an example. Okay, so we have our plus or minus 1/2. Okay, so let's just begin to build this matrix. So for example, I'm just going to go in order kind of like that. So we have our 0, 2, and we have our 3, 0, and we have our 0, -2. Okay, so each point is shown here, and that makes the first two columns. And the third column is all ones. So 1, 1, 1. All right. So I'm taking the determinant of this 3 by 3 matrix. Now, the way we find a determinant, one of the ways is by using diagonals, and that's how I'm going to do it right now. So to form the diagonals, I need 2 extra columns. So I'm just going to copy the first 2 columns here. So that's going to give me 0 and 3 and 0 and 2 and 0 and -2. Now, the way we do it is we do the down diagonals minus the up diagonals. Down diagonals minus the up diagonals. Okay, it's very similar to the way we were doing the determinants of a 2 by 2 matrix. We did one down diagonal minus one up diagonal. Okay, and we got an answer. The only difference is there will be 3 down diagonals and 3 up diagonals to deal with. So here's what I mean by that. Starting from here, here's one down diagonal. Here's another, and here's a third. Okay, those are my 3 down diagonals. Let's go ahead and get that out of the way first. Okay, so we're doing down diagonals minus up diagonals. So the down diagonals are, and I'm multiplying here, 0 times 1 times 0 times 0 times 1. That is 0. 0 times anything is 0. Now the next one, 2 times 1 times 0. Again, that 0 wipes everything out. I just get 0. Now the third one, 1 times 3 is 3, times -2 is -6. So that's my down diagonals. Now the up diagonals are going to look like this. And you know what? This time I think I'm going to erase my down diagonals. All right, now my up diagonals are looking like this. Here's an up diagonal, and there's another up diagonal, and there's a third up diagonal. Okay, so let's write those down. So the first up diagonal is going to be 0, right? 0 times anything is 0. The second, again, is going to be 0, all right? Because of this 0 right here. The third is going to be 6. Okay? So, to sum it all up, the down diagonals boil down to, whoops, -6. I don't know where that 2 came from. Alright, 0 plus 0 plus -6 is just -6. So my down diagonals minus my up diagonals, which are 6. Alright, so -6 minus 6 is going to be -12. Okay? Now, so that's my determinant. Alright, but we have this business of the plus or minus 1/2. Okay, so really right from the beginning, I'm doing plus or minus 1/2 of all of this. Alright, in fact, just to be consistent, I will use the little square brackets now. So plus or minus 1/2 of -12. So 1/2 of 12 is 6. So I need to always make sure that this area is positive. So that means the area of the triangle is 6. So that is how you use matrices to find the area of a triangle. Who knew? Okay. Now you might be thinking it would have been easier just to do 1/2 base times height, and that's true for this problem because the base is here and the height, so the base is 4, the height is 3. So I could have done 1/2 base times height, and that would have been 1/2 12, which also would give me 6. All right, that's just confirmation that it works. But two things. When the triangle is randomly spread out over the grid and not lined up nicely for you, this actually can be easier. And also, if you ever need to program a computer to find area and all you have are the vertices, then this is a way you can get a computer to do it for you. Okay, computers are good at doing matrices. Let's go ahead and do number 6. How many of these we got? 6, 7. All right, man, we got a few of these. All right, I better accelerate the process or this is going to be a 2-hour video. Okay, I'm going to start speeding up a little bit now. I hope that is okay. So I need to do plus or minus 1/2 of the of this determinant. So I'm going to do -1, 2, and I'm going to do 3, -1, and I'm going to do 2, -3, and then just fill in the rest with 1s. Okay, so that's going to be -1. Whoa, did not mean to put -3. It's going to be -1, 3, 2, and then 2, -1, -3. Okay, so this is how I find that determinant. So now I'm going to do my down diagonals minus up diagonals. So here are my down diagonals. Here, here, and here. Okay, so my down diagonals, that's going to be +1 plus 4 minus 9, negative 9. Alright, so that's my down diagonals. Now I need minus, and then I need my up diagonals. Okay, so my up diagonals are here, here, and here. Alright, so that's going to be negative 2 and positive 3 and 6. Okay, and this is how I will get the area. Alright, so that area is going to be plus or minus half of, okay, let's see, so this is 5, this is 5 minus 9, so that's negative 4, and then minus, okay, negative 2 plus 3 is 1, plus 6 is 7. Okay, so that is negative 11. Negative 4 minus 7 is negative 11. Okay, so that's going to give me 11 over 2, which is 5.5. Okay, that is the area. Okay, number 7. Alright, so I'm setting up the formula, and I'm using my 3 vertices, negative 3, 1, my 2, 0, and my 3, negative 1 right here. And then the third column is just all ones, and then I'm just going to recopy. So this is going to be like this. First 2 columns copied over again. Alright, so now I need to do this determinant, and I do that by doing down diagonals minus up diagonals. So these are my down diagonals. The first one gives me 0 because that's 0. Then I have positive 3 from this one. And then I have negative 2 from this one. So that's my down diagonals minus my up diagonal. And these are my up diagonals. So I'm going to get 0 because of the 0. And then positive 3 from the second one. And then positive 2 from the third one. Okay, so that's going to get 3 minus 2, that's just 1. Alright, and that's just 5. So 1 minus 5, that's negative 4. So that means that the area is equal to 2. Half of 4 is 2. Okay, so that is the answer for number 7. Alright, let's just do a few more. So number 8. The area is going to equal plus or minus 1/2 of this determinant. So to build my determinant, I'm doing 0, 4, 0, 0, 2, 0. That's my 3 points. Okay, for the other part, I just use ones. 1, 1, 1. Okay, and now I recopy the first 2 rows again. So that's just going to be 0, 0, 2. I'm sorry, copy the first 2 columns. So 0, 0, 2 and 4, 0, 0. So to do this determinant, I need to do the down diagonals minus the up diagonals. But so here are the down diagonals. Okay, so that's 0, positive 8, and 0, minus the up diagonals. Okay, so up diagonal, up diagonal, up diagonal. Okay, so that is going to be, it's a little bit hard to see. Make these go away. Okay, so those are my up diagonals. So that's going to be 0, and 0, and 0. All right, they all have zeros in them. Well, that's going to make the math pretty easy. So the area is going to be plus or minus 1/2, and this is just 8 minus 0. Okay, so the area, half of 8 is 4. So for number 8, the area is 4. Okay, 2 more left. Really just the same thing. And if you're getting these right, then you should not be watching this video at all. You should be doing the problems yourself and just simply checking your answers using the answer key. Alright, but I'm going to follow through just in case. This is the problem somebody really needed. So if I want to find that area, once again, I'm going to do, I'm sorry, I forgot my plus or minus. Plus or minus the determinant, which I build by doing 0, 3, negative 3, 0, 3, 0. Okay. And I put a bunch of 1s here. 1, 1, 1. And then I recopy. So 0, negative 3, 3. And 3, 0, 0. That's the bell that means I'm supposed to go have lunch. But I'm going to finish this problem first. There's a small chance I might not get to do number 10. But I think I've done plenty of examples for you guys. Okay, so let's finish this up. Down diagonals minus up diagonals. So that area is going to equal plus or minus 1/2 times the down diagonals minus the up diagonals. So the down diagonals are like this. There's one of them. There's one of them. There's one of them. Alright, so my down diagonals are 0, positive 9, and 0. Okay, my up diagonals. There's an up diagonal, there's an up diagonal, and here's an up diagonal. Okay, so that's going to be 0, and 0, and negative 9. Alright, which means that the area is going to equal plus or minus 1/2 9 minus negative 9. So that means that the area is equal to plus or minus 1/2 of 18. Which means that the area is equal to 9. Okay, that's number 9. You know, just one problem left. I'm hungry. Can you guys see my dedication to you? Do you see what's happening here? I'm skipping my own lunch. Hopefully I won't miss the whole thing. But let's bust out this last problem. Rapido, right? Quick. The area will be, once again, plus or minus 1/2 the determinant. Alright? And the determinant will come from 1, 1, 5, 1, 2, 6. Okay? And then I will fill in 1, 1, 1. And then I will copy. So this will be 1, 5, 2, and 1, 1, 6. So the area will be plus or minus 1/2 times the down diagonals minus the up diagonals. Oh, I'm running out of space. Okay. The down diagonals. One more time. I always like my down diagonals to be yellow for some reason. So, down diagonal, down diagonal, down diagonal. So that's going to be 1, and then positive 2. Okay, because 1 times 1 is 1, times 2 is 2. And then 30. It's 5 times 6 is 30. Alright, that's my down diagonals. Now let's do the up diagonals. Whoa, wrong tool. Okay, up diagonals are like this. There's 1, and there's 1, and here's 1. Okay. So up diagonal. So this is going to be 2, and then this is going to be 6, positive 6, and this is going to be positive 5. Okay. Let me see if I can just bring this up over here. So the area is going to equal 1/2. I'm sorry, plus or minus 1/2. Now the down diagonals were, this is 33 minus the up diagonals. That's 11, 13. Okay. So the area is going to equal plus or minus 1/2, alright, of 20. 33 minus 13. Okay, which means that the area is going to equal 10. Half of 20 is 10. And that is it. That is how you use a matrix to find the area of a triangle. Alright, I hope that was helpful. I'm gonna go eat lunch. I will see you on the next video.